At the moment, yeah. Yeah. Some.
A lot of people.
So. Oh. All right, looks like we've this. I guess we can get started. Welcome everyone to the AstroAI lunch seminar. In case you were not done with agents from last week, we're going to have more agents today. And it's my pleasure to introduce Zesen Huang from UCLA, who we met during the AstroAI workshop recently. Gave actually a nice primer on how to orchestrate these agents for some heliophysics work. So Zesen is a postdoc at UCLA. He also got his PhD from there in 2024. And he's gonna tell us all about how to use the systems. By the way, he told me today that some of the, DeepSeek models are now less than $1 per billion tokens, which means
Per billion.
but anyway, please take it on. Thank you for coming, and as usual, please feel free to interact. We have a full hour. Thank you.
Thank you. So thanks for your invitation, and it's a pleasure to talk with you. So please interrupt me whenever you want. I want to make this very interactive, very casual. So the title is like very catchy, right? So AI agent as Genies and wish-driven research. Where you work, like there's a lot of words here. What is wish-driven research anyway? Actually, how many people here actually completely offload their research to agent? One.
They will not accept it.
Oh, okay. If they're accepted at UCLA, I guess. Okay, so let's get started. So like 5% of people here offload their research to AI. I guess that's going to be the trend in the next few months that most people do it. Why? So I guess this is a genie. Like the ultimate goal is that I'm going to make a wish. Yeah.
I have a question
Yeah.
about what you mean by offloading your research to an AI.
Like
Is it making scientific decisions for you?
like do research. Like if you like being a professor, typically you offload some of the research to your students, like guiding them, like you teach an AI as if you're teaching a student. That's what I mean by offload. Does that make sense? Kind of. So what I'm saying here, personally, I'm treating AI as a creature. So I'm trying to teach how to do my research and how to make them do original research. Like the way you teach a student, a PhD student, how you guide them to do research. The ultimate goal is that I want to make a wish and output FJL. That would be a perfect world. Maybe not perfect world. Okay, so this is a bit of background, like how crazy things are. I guess a lot of people are behaving like me. This was the slide I showed 2 months ago at AstroAI, at like 8,000 commits to GitHub in the last year, and this is 2 months. Since then, I have 4,000 more. So I guess that's like pretty wild. I think lots of people are doing the same thing as me, right? I hope. Like basically, okay. So that's a little review of the recent history. Like pre-2022 is like Stone Age to people, I guess. Okay, so what is happening here? So in 2022, we have GPT 3.5, which was a surprise to everybody. And to me, I couldn't forget the date when GPT-4 was released, which was, and people remember when was this stuff released? Anybody remember the exact date? Okay, it was the Pi Day of 2023, so March 14th. And then in 2024, a lot more models comes out, but before 2025, most of the AI usage was in the form of Chat GPT, right? You go to Chat GPT, you ask the question, and then output the answer that tells you what is happening to the question you ask. It's not like actually doing a lot of things. And then in 2025, did anybody here actually use Cloud Code in 2025 early in 2025? Yeah. When did you start to use Cloud Code?
I don't know.
Huh? What?
It was like midway through 25, I think, in the summer.
Yeah, exactly. That's the same. I think that was the pretty much the time it was released to the public. It's like June, July 2025. Okay. That was when Cloud Code really came to the world and really exploded the usage of AI. Why was released back then? Just because Opus 4 was released in May of 2025, and that was the model that actually make the agentic use of these AI agents both financially possible and feasible. Right. Before that, those models could not even like output JSON very in a very reliable way, but Opus is the first one that makes this thing both financially and scientifically possible. And then from the sake we have all of these. Some people are using OpenChrome here. Try Hermes. Do you even know what the Hermes agent is? I guess not like Hermes bag, but Hermes agent. Okay, and I guess you know all of these. Okay, and this is really the latest progress. As Rafael mentioned, if you has anybody really tried this, this is like this thing is for Flash, which was July 31st. This is really crazy because it's like Opus 4.6, but at 1/10,000th of price. So you got a billion token for $1, which is basically free. Okay, so this is all kinds of agent that you can use now in public. They're all very crazy, very useful. So before I really get started, I'm going to do like repeat my part of the call of my AstroAI. I'd say why do I need to use AI anyway? Because this is AstroAI workshop, so I'm going to talk about a little bit of astrophysics. So this is the stuff I mainly works on. I works on atom web in the solar wind. Mostly the physics of atom web, like what part of solar probe actually tells you about new physics of atom. I hope some people here actually do atom web. Okay. I really hope that you don't think I'm pseudoscience because this is not necessarily astrophysics, right? Okay. Bit of history. So atom web was introduced by Hans Alfvén in 1941, right? This was the Nature paper, Hans Alfvén in 1941, which there's this genius idea that what if you combine Maxwell equation with fluid dynamics and simplify the equation in the limits of non-relativistic and those kind of things, the output and then they'll produce a wave that is really new. That the magnetic field and the velocity field will fluctuate together and create something that looks like this. Like that. So this was the wave envisioned by Hans Alfvén, that if you have the background magnetic field, you fluctuate the field, and then the magnetic field, the perturbated part of the magnetic field will correlate perfectly with the velocity part. So you have the V1 and the V1 that perfectly anti-correlate, and then it will propagate this way. And this will partially, because of this, it gives Hans Alfvén the Nobel Physics Prize. Okay, the only problem is that it's not really correct in reality. So this is where it's talking solar flow. So this was the solar eclipse in 2024. The closest approach of partial solar flow is at 9.86 solar radii, which is right here. So to look at the picture of solar eclipse, this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how close the solar flow is actually approaching. So as you can see in the picture here, solar flow is actually doing in situ measurements of the plumes. And you see it during the eclipse, which is really cool. What do we see? This is what we see. If you fly close enough, the magnetic field close to the sun is remarkably interesting. So you see a black line here. That's the magnitude of the magnetic field. That's how constant it is. And this line is the same line. You can see the average value is about 1,000. The amplitude is of the magnetic field is fluctuating around 20, 30 nanotesla. Right? It's very constant. It's basically a straight line here. But the free component is fluctuating very wildly. This is a component of the R direction. Right? These are basically magnetic field, right? You can see they're pointing radially outwards. But if you fly close enough, you see it actually fluctuates backwards. This is like really crazy. How did that even happen? The magnetic field will actually do this. And this is what the solar flow people call a switchback. Why it's called a switchback? Because if you look at the topology of the magnetic field line, right here is the measurable is the pitch angle distribution of the electron stroke. So because these field lines are one-sided, right? The electrons will follow the field lines and go to infinity. Then a source from the sun and goes like this. So if you look at the pitch angle distribution of the magnetic field, it's one-sided, which means that even if the magnetic field go backwards, it's still aligned with the magnetic field locally, so that the field line actually the field line is topologically open. So this is what it looks like in a like artist depiction. So the field line actually goes like this. The electrons will go like this and follows the field line and go to infinity. This is what the magnetic field looks like close to the sun. And as you will notice, this looks nothing like the original alpha wave that's proposed by Hans Alfvén, because it's very large amplitude and it's solitary. It looks like quasi-particle. And you have unperturbed part, you have unperturbed part, and you have perturbed part. And this kind of thing cannot be explained by Hans Alfvén original idea of alpha wave. Right. So this is a big question raised by Parker Solar Probe mission when it was launched a few years ago. Is that how to explain these waves? What are them anyway? So if you think about it very carefully, it's actually a very straightforward mathematical problem. How are we going to create a 3D vector field that satisfies all four of these constraints? That you have a quasi-constant magnetic field magnitude. You have the field has to be divergence free, right? We don't have magnetic monopole. And the field line has to be open. It cannot look like a tokamak. It cannot be a donut shaped magnetic field line. That's not what it looks like in space. And the fluctuation has to be solitary if you want to have the proper solution. How do we solve this? Because this is like a problem that's clear enough. I actually use this problem to benchmark the development of AI. Starting from 2022, I actually showed earlier, starting from ChatGPT 3.5, I asked the exact same question to ChatGPT every 3 months to check how AI is progressing. As you can see, in the first 3 years, nothing happens. I asked the question, said, okay, I cannot solve this, and I'll put some.
What was the question?
This question: how to create a vector field that satisfies all four of these. This is a well-defined mathematical question, right? Just give me an example. 2022 to 2025, nothing happens. I ask the same question every month, it just up to some gibberish. Until until I did the same thing last year, summer of 2025, I asked, oh, okay, how to construct a 3D vector to satisfy both? Said, okay, how do I enforce this first? And then enforce another one, and then you repeat. And oh, wow, this is a genius idea. How could I not think about this? And how could no one in the field actually ever think about this? That's like crazy to me. And if you implement that, this is the algorithm that you input some initial field, whatever field you like it doesn't even need to be physical. The initial field just something that's it can contain divergence. But you just repeat this process, they remove divergence from the field, and then that will make the field non-constant, and then you normalize it, which will you introduce divergence, and then you normalize it again, you introduce and then you introduce more divergence, but you can remove divergence, which will make the field non-constant. So you do this alternating projection on two constraints, and out to the result. We actually create a solution that looks exactly like the one you see in space, which is pretty crazy. So these are ISO value line, ISO value surfaces of the deflection angle of the solution. Okay, so this is what the field line looks like in 3D. It's remarkably beautiful to me. Not sure if it feels right, but yeah.
Could you go back 2 slides?
Yeah.
Look.
This. So,
Yes.
Okay.
Can you go through it like?
Yeah. So you have an initial field. Okay. Initial field is a 3D, whatever field it is. Preferably, the initial field should be topologically open. Okay, you input a random field that is topologically open, and then you solve the Poisson equation to move the divergence. Like this, you can move the divergence perfectly to the precision of the machine noise, and then normalize the field. Once you normalize the field, the divergence is reintroduced to the system, and then you just go back to this. You solve the Poisson equation again, which introduce non-constancy, and you just do repeat it.
Sorry.
Yeah.
I want to ask a question about this too.
Yeah.
So. This kind of general procedure has been in previous papers in astrophysics, and maybe you're gonna get to it, but I'm curious. You know, what's the unique role that the AI?
Yeah, so the unique role is that I didn't know this. They had told me about this. That's why, because I was not knowledgeable enough to solve the problem, and not people in our field was knowledgeable enough or right enough. Or maybe just it doesn't come to them. So I think this is a very common method, right, in optimization theory. This itself, but I'll discuss this, like why this is really non-trivial for AI to propose this, because this is not a conventional optimization problem. It doesn't have guaranteed convergence. Actually, it doesn't guarantee convergence. Okay, so this is what field line looks like. It's pretty cool. All right, so and then because of this, can do this kind of simulation that the collision of alpha wave, which is probably also useful for fast radio bursts, by the way, because people use alpha wave to explain fast radio bursts. But let's see, it allows you to do this kind of simulation that you can see that they collide and then annihilate like the electron and positron. So the particle collided, completely annihilated. Anyway, so this is going to be true. So this is original alpha wave proposal as thing. And then this is the actual alpha wave that you see in space. And then you reconstruct the whole thing. Because in space, you have to measure this in 1D, you never measure this thing in 3D, but you can reconstruct this in 3D. Okay, so what is actually happening here, to answer your question? I call this knowledge arbitrage. Because this is a very common method in optimization theory. That if you have two constraints, you want the solution to satisfy both. You just do the alternating projection. The problem is this is not a convex constraint, it's non-convex. So there's no guarantee that this thing will converge. It's actually a miracle that this thing actually converges. So so this is the paper that was published a few days ago. Okay. So this is like kind of a democratization of knowledge, right? In the past, you need to search for information. But now, if you ask AI, ask a proper question, it will generate a series of ideas proactively to tell you what kind of new method you can use to solve your problem. The key is that there's an imperative of innovation appreciation. So in the past, innovation is terribly hard. If you want to innovate an idea or you want to borrow something from the other field, you need to read the paper, you need to read you need to read the new books, you need to read whatever theories they are, you need to learn them very deeply. And then you can introduce that idea to your problem. But now, this innovation is outsourced or can be outsourced to AI. You can kind of outsource the innovation process to AI, and your part becomes appreciation. So in the past, appreciation is kind of like underappreciated process of science discovery. Okay, I hope this is not like unconventional or kind of. So in the past, if you all of the like the glory goes to innovation. If you introduce some idea that lots of people can appreciate it because this thing is scarce. But now this thing becomes abundant, and this thing actually becomes scarce because you need to know the problem very, very deeply so that you can appreciate that AI is not bullshitting. And most of the time AI is actually bullshitting to you. Okay, so in the past it's like this. You have a professor, you have a student, you discuss for many, many years for a very hard problem, and then you finally innovate something that is very scarce and happens not very often. But now for AI, this thing is industrially produced. You have industrially produced innovations, and then the burden is now the human that you don't have enough energy to appreciate the innovation. So it's like it can constantly make some wishes, but you don't even know whether your wish is a proper wish. So I want to borrow this slide from Terence Tao from a few weeks ago, actually 2 weeks ago. It said what happens mathematics in the age of AI. It's like mathematics is the field that's influenced by AI so deeply that it completely kind of destroy the credits system, like how I'm going to credit people, what I'm going to credit people. So this is the side I really want to talk about, is that in the past you have a scarcity of proof. It's very hard to prove some problem, right? But now you can ask AI to prove the magnetic problem so easily, as you can see on X or Twitter. Like tens of hundreds of other problems was proved in the last few weeks. But now the consumption of these proofs become the bottleneck of humans. So in the past, once you have a proof, you have a lot of people to do this work, and then this work is kind of not being appreciated at all. But now, because this is so abundant, this part will be appreciated. I think this is pretty much it's going to be the same to happen to our field in the near future. Okay. Any questions now? Yes.
Are you confident AI won't take over appreciation part of the task as well?
No, I don't think so, because by definition, appreciation is a human job. It's for teaching other humans to know this. It's not because we have like a limited amount of attention and energy. Human need to explain things to human, I guess. I hope.
I'm not sure.
Okay. I kind of think that's in the short that's going to the short-term status quo, because humans are now much more stupid than AI, to be frank. Like most humans, probably not people here, but most humans. We need to be very honest that we are less smart than AI. Then we need to teach each other how it's like the AI give you an oracle, you need to explain the oracle, like the human will be the people that going to explain the oracle that is produced by AI. That's a sad fact, but I think that's a pretty cool thing to do, yeah.
Can you be precise on what you mean by these things are smarter than us?
Uh, it's like my daily experience, I guess.
But what do you mean?
Like,
Because Google, I think by the definition that I think we're colloquially using, Google is smarter than that. But so is a book, right? So is any book I haven't read. So what do you mean precisely by your saying that it's never smarter than us?
it can think faster than us, so it can mass produce innovation. Like human is terribly bottlenecked by their attention. You have a limited amount of energy per day to do innovations, but AI doesn't sleep. And AI can also do logical job very seriously for long running jobs, which is much longer than what a human can basically do. I guess that's what I want. I try to define why AI is smarter than human, but that's my own definition. I hope that it says right there. Oh, you agree with that? Okay, so so in the past we have the scarcity of intelligence. So all humans is bottlenecked by this. We've been repetitively talking about this in the last few minutes. But the future is we have abundance of intelligence. So innovation become abundance, appreciation become very important. And if you seriously think about it, what AI is doing and what AI is actually doing to our job or to the world anyway, is that AI is trying to push every field to the limits of to the physical constraints. So in the past, because we have a scarcity of intelligence, a lot of things is clogged by human intelligence. We don't have enough human intelligence to do enough innovation to push the physical limit. So, for example, you have an instrument, and this is the status quo that leverage it. There's a difference between that, but AI can push you towards the physical limit very quickly. If you leverage AI properly, but AI is not going to change the physical limit anyway. So people still have jobs. I don't think people should be very pessimistic about this. People will still have jobs because with AI, you can do much more things. You can do a lot of things that can never ever imagine in the past. And then our job is to leverage AI to push to the physical limit of every single instrument. Okay, so before I get into the hardest part, I want to discuss because I have personal interest in this, what AI means to us anyway. This is what AI means to me is an industrialized intelligence on demand. It's a mass produced intelligence, it's basically turning silicon or sand into intelligence that human needs like 18 years to grow, to mature, to do serious thinking, but AI can do that in 6 months, I guess. So these are data centers in the US. These are operating. We don't have many of them. These are the plan. So to give you a perspective of this is the total gigawatts of these are data centers measured in gigawatts in the US. The blue one is the one that is operating. That's already outputting intelligence. The orange one is under construction. The purple one is the planned data center. You can see it grows exponentially. Can anybody guess how much electricity is being consumed per in the US? It's measured in gigawatts on this graph. Can we guess? Like our daily consumption of the whole nation. Okay, it's this value, 20 something, which is right here. Believe it or not, AI is going to consume an equal amount of electricity if all of these are constructed. And they will be constructed in 2 years. Which means what is AI anyway? It's a new industry. It's going to increase our energy consumption in terms of electricity by 100% in 2 years. Yes.
Is that when they come online or when the planning permission hits?
Sorry?
So it says the purple one is planned pipeline,
Yeah.
but that would come online in 2026?
So that will come online in 2030.
Okay, yeah.
Yeah, they're being planned because there's people are not happy about data center, right? There's actually 50% of these planned data center will be rejected by local county committee. But there will be more be proposed, so I guess this value is kind of like will be a factual value in 4 years, so
Okay.
3 years. So in 3 years, we as human will like double our energy consumption in terms of electricity, which is pretty remarkable, at least to me. Okay. So I usually think about this question or this problem in terms of energy consumption because all physicists. How to measure like the capability of a civilization is basically how much energy you consume per day. So if you think about that, if whenever burn tokens actually consume energy, so how many tokens you need to spend per day if you are to like outperform yourself, consume energy daily, right? If you how much token you need to burn per day that you can spend more energy that you yourself spend, and that answer is lies right here. So we usually use this method models, right? The mythos, fables, outputs, whatever. That will spend about 5 joules per token for token outputs. For cash input is like 110 or 120. So on average, if you spend 1 token in terms of the cash and like the thinking whatever that is, like cash means, you spend about 1 joule token. And how many joules you spend per day? And that answer is this. Including our clothes, including our cars, whatever, you spend about 778 billion joules per day. So if you spend more token than this, you outperform yourself. So I hope everybody try to do this. Is anybody constantly doing this right now? That's spent more than 700 million token per day. So
What is the metric again? It's consuming more energy in clothes than in food.
than yourself. So this is the average.
Oh, everything, okay. All
Yeah.
consumption.
That's like including your clothes, including your cars, whatever. And if you stand here breathing, you're going to spend this amount of energy per day. Yeah,
How many tokens would that be for a Mythos class model?
this
Yeah,
similar amount, so 700 million.
and that's the joules.
Yeah, so you spend a 1 joule per token on average.
Ah, okay, I see.
Yeah. That's the same like the doing astronomy, right? That all the magnitude is fine. This is like pretty precise, right? So give perspective, I spend around like 3 billion token per day, so I doing good. I hope people spend more. Okay. All right. So this is I'm trying to explain that. Let me explain. So what is actually happening right now is that Mythos is still expensive. I spend like $600 per month on subscription. I have 2 Codex Pro and 1 Code Max. I basically use all of them. But as of a few days ago, you can get an Open Code Go. You subscribe to that. It's $5 in the first month. That actually gives you 13.8 billion token in DeepSeek. So you actually get 1 billion token per dollar. So it's like imagine the case. So we still now have a scarcity of tokens. Imagine if you are forced to spend like 10 billion tokens per day, what are you going to do? I think that's going to be the short-term future because these things are so cheap. You are going to spend that amount of tokens per day because in the past, for example, you have a scarcity of electricity. You couldn't even imagine what you can do with the amount of electricity, but when you are given that amount, you can actually do much more things. So that's why I say we should be very optimistic about the future that tokens will be basically free. Yeah.
So who's costing out the $1 per billion tokens? Was it what company and how
Yeah.
did it?
We used to spend $1 to get a billion tokens.
So who are you giving that $1?
This is
Okay. How are they generating electricity costs that would be associated with this?
Well, for now, China is paying the bill for this. But it's not that expensive to produce tokens. The reason why you spend that much amount in tokens now on those subscription plan or you charge for API is like 10,000 times more cost than this is because you need to pay for the depreciation of the GPU. So if you
That, I appreciate that, but that's not what I think we're driving at. I'm asking if we happen to know if you're costing the per token cost so low, that presumes that the electricity cost also has to be that low.
Yeah.
Or it's being right, or there's some, right, you're saying the Chinese state is in some way kind of like mitigating the costs.
Yes.
To ensure more subscribers. What is actually generating that electricity?
Cold.
Okay.
Yeah, so if China's paying this, it's basically 50% coal, 30% wind, 20% solar.
Okay.
Yeah, I think that's also going to be a future here.
Yeah.
So we are now kind of entering this age, right? The age of wish children. You're trying to make a wish to agent, output FJL. That's like a semi true fact now, but it's not like too true. I guess people try to do this here in this room, right? Has anybody tried to ask the agent that write me FJL and tomorrow I want to submit it? Like,
Well, we wrote a paper last week here.
perfect. And then
We didn't submit it though.
okay. If you do that, you realize that AI is not that great. It's not that great in a lot of sense. Okay, AI can do data analysis very perfectly, but it cannot really write a good paper. Yes.
What about reproducing a paper?
Oh, that's like very easy.
Okay,
If you give the AI like enough GPU or CPU, whatever resource you have. I tried it multiple times, and it just worked. But producing new one is terribly hard. I mean, producing my my own work because I give it the proper prompt to produce the stuff. But actually producing a new one is like not that easy. The problem is there's a lot of layers of problems here. But one of the most serious problems is this: if you are a very heavy plot user, you probably notice this. If you open one plot code session, it's okay. What if you open this? If you open 5 plot code sessions, you start to lose attention. Yeah.
So we had a question online. What happens when the state and VC subsidies end and people are forced to pay the actual energy costs? So that, like 2 minutes ago, kind of thing.
They will. I don't necessarily think they will lose money because the value being created, they will capture the value at some other places. But in terms of energy, I think they're subsidizing. That's what I think.
Right. That's the question. So what happens when those subsidies go away?
I don't think they will ever go away. Because we have dancing law. Because of this. Let me tell you. Why DeepSeek is so cheap? Because this thing is only they only have 10 billion token, 10 billion parameters being activated versus Opus. So the new DeepSeek V4 Flash 0731 it has performance in par with Opus 4.6. Opus 4.6 has maybe 50 billion tokens activated, but this thing only have 10 billion tokens, 10 billion parameters activated. So actually consume 1/5 of the energy to do each of the token production. So that's one way to save energy. You produce model that's simply smaller and more intelligent.
So Ariel, you want to unmute yourself and ask, since this was your question?
Okay. Okay. So people call this dancing law. And I'm not like really an AI expert, but my friends doing AI. I realize this is a fact that you can the frontier models now in US, they activate a lot of billions of weights, but the actual weights that need to create this kind of intelligence is not that many. But you need to spend time to optimize that. But there's no incentive here for them to optimize that. but there's incentive for Chinese automatons because Chinese doesn't have like the latest GPU. Okay. So this is what I really want to talk about in this talk is that the human attention is actually very very valuable resource that we have, and we have a problem with that. If you are doing if you're doing basically the same thing as me, that you open like 10 cross sessions on your terminal, maybe 20, you realize that you cannot really remember what are you really doing in each of the sessions because you have a limited amount of attention that you really need to protect, but we don't have the idea to actually protecting it before the age of AI. So the problem is these things, they don't have identities. Who are you? You open the Claude Code, you ask who are you, it says I'm Claude Code. It's not going to say I am who, that if I talk to a professor, he said, okay, my name is Marco Velli, or talk to another student, my name is blah, blah, blah. When you talk to Claude, they say, okay, I am Claude Code. That's the problem. These things actually consume a lot of your attention that you will lose track of your work. So this is the problem. If you have this many of these, you cannot remember who they are. If you know this problem very seriously, who are us anyway? Like who am I? I am defined by all of these. I have my life experience. I have my life experience of my 28 years of life. I am also defined by my social connections. That I connect with other people, I talk to them. Our connection, our topology actually define who I am. That's a very crucial definition of my identity. Also, I have short memory, long memory to my knowledge. Oh, I short this, whatever. Can this be ported to AI? The answer to that is kind of yes. If you use Claude Code, that's a coding agent that is designed to be optimized to coding. It's not designed to be a personal assistant or a creature-like agent. But if you create a new kind of AI agent that actually have an identity, or you force it to have identity, which means that identity being the life experience of AI is its traces. The social connection means that you need to make the system a multi-agent system. That the AI has to be interacting with AI. That you let the AI to do very, very constant interaction with other AI, which define themselves because you have this kind of connection topology. And you have a memory of system of AI. So to organize this, we have a lot of agent harness on the field. For example, we have LangChain, that this is very famous back in 2024. You can use AI to power it. It's basically using AI to create a tool. It doesn't have to have any kind of identity. And you put Claude Code here. Claude Code has some sort of identity. Claude Code is Claude Code. You can use Claude Code to code, but it's a tool for you to code. And then OpenClaw is right here. Okay? Why OpenClaw becomes so famous? Because OpenClaw is the first agent harness that actually gives you the vibe of that it looks like a creature. You can interact with it as if you're interacting with human. We can put a Hermes agent here. The Hermes agent is very kind of human-like. It has the quote-unquote self-evolving feature of it. And this is my own agent harness that I think I try to make it the ultimate creature-like agent that give you an extremely strong creature-like feature, because to make it creature-like, you need to make it a social agent that you interact with each other. So you can try my own harness right here. So GitHub has 600 stars right now. If one can give a star to it. Have a few tens of people using it. Okay, so before I get into that, this is the talk given by alumni here back in the AstroAI workshop. So has anybody tried to submit a task to this one? Okay, I actually follow the code by that, right?
I've tried.
You tried. Okay, if you try really hard to submit to this one, you realize that it's terribly hard to submit a task that AI cannot do. Unless you're trying to deliberately challenge it, that you feel like you're not making a problem that is, they're not making a problem, but you're making a problem that is deliberately unsolvable to AI. So if you really trying to challenge the frontier AI, realize it's terribly hard to actually form a question that AI cannot solve. Yeah, it's really smart. They basically solve most problems in 3 hours if you're given enough resources. The problem is what is AI still underperform? It's this. If you try to make a wish, say, please make a black hole simulation code to me. It's that it's not really doing great in this. You try. So for example, my own question that I'm trying to solve right now is that, okay, how can I use the alpha wave solution to improve our understanding of the fast radio burst? Because one of the leading mechanism of fast radio burst is that you shoot alpha wave from the from the star, and then follow this, and alpha will return to fast wave, blah blah blah. The problem is all of those simulation was done using linear alpha wave. It doesn't carry enough energy, so the solution was not that satisfactory. But I think with my solution, I can make this kind of work better. The problem is AI is not really good at generating this kind of simulation yet. So AI is not a genie yet, but how can we make it a genie? The key is that AI is still not doing very well in GPU coding, also in translation of scientific code, because the scientific code is not fully appreciated or consumed in the pre-training process of all these models. So we are proposing a benchmark, which is called the science acceleration bench, to let the AI to translate our CPU code to GPU code of all the existing simulation code that you have. Say, let's say you want to rewrite your Fortran code in the CUDA, or you want to write a Fortran code on your Mac GPU. If you try that, you realize that it can, theoretically speaking, increase the speed by 10x. But if you let AI do one shot, it can probably do 2x or 3x. You need to iterate with the AI multiple times to really make the code work on GPU. So our ultimate goal is that to make this benchmark so that AI can one shot create a code that can run on any GPU that's very close to physical limits. So if you like, you can scan this website or join our Discord channel or join the Discord channel of my own house. And yeah, any questions?
Thank you. I actually have a question. So, regarding the ability of these models to actually pass sort of human tests for science. Maybe Ariel was asking questions online, is still there, but she shared with me a paper this week about some folks that took some papers that had been accepted but not yet published or nearest, and pass it on some of the tasks related to the resolution of those papers to an agent with a bunch of money for tokens, etc., etc. And then had the agents write up the results.
Yeah.
And then had the humans evaluating the models. None of these papers got accepted by the humans. I guess there are some parts of the inference aspect of what we call doing science, other than the engineering, that these models might be still missing. Of course, this is one study among many others that are trying to measure the performance for like full sort of cycle scientific tasks. But do you have any comments on that?
You mean a comment on why they are not being accepted?
On whether you actually think that these models can do anything when it comes to science,
I don't think so.
including writing papers.
And writing papers is something that you only need to move electrons to write papers, right? You don't need to move atoms. You need to do physical job.
Right, but papers that would actually get accepted by a panel of experts. I don't know, this is more of an open discussion, so I kind of want.
There's a prejudice here, right? The human has naturally have a prejudice over what kind of paper they like. And that's not necessarily aligned with what the AI is producing. Actually, it's not going to align with the AI.
That's an interesting point, yes, Matt. Sorry.
Thank you very much for a thought-provoking discussion. Perhaps this is germane to the subject Raphael just raised. I like your word appreciation quite a bit. There's a lot that can fit under that word. Love, joy, excitement, but also a lot of negative words too would fit under that word. I wonder if you have any comments about proactive forms of appreciation, which I might call intent. We as scientists might like to think that we are in charge of what direction science is taking and originating the projects that we are embarking on, and not just appreciating, responding to the outcomes of those projects, and maybe eventually in a distant, I might say, unhappy future, serving as oracles to godlike AI. That strikes me as kind of an unhappy future, personally. That's just my opinion. Do you have any thoughts about us humans appreciating what we cause to happen and the roles that we play interacting with AI in that capacity?
I think that's a very, very hard thing to comment. My idea is that AI still doesn't have agency, right? It doesn't do things proactively. Humans still have the role to use AI to do research. It's like the way we use the internet. The internet comes out because it's making it much easier to search for things, and there's a bloom in papers. I think this is pretty much the same thing happened to AI. It's a new internet. It's a way that it's a new method that enables humans to do much more things and spend much more energy and do stuff. As humans still have the leading role to control the AI and use the AI to do the work, because you have the responsibility of your research or of your work. That's what I think. And in the sense that it's sort of like you're taking a role of explaining the oracle from AI, but you are the one that create the oracles. So I don't think it's that pessimistic, because you need to kick the AI to create oracles, right? I hope that is a satisfactory comment to the question. So, yeah.
Comment here.
Sorry, Ariel, you wanna, say what you're
Yeah.
gonna say?
Thank you. And sorry, earlier my laptop decided to choose that exact moment to freeze when I was being asked to unmute, so apologize for the interruption. This has been a very interesting talk. I do stand by my statement earlier that we are not going to, this is at the moment we're experiencing an era of very heavily subsidized models and costs associated with the models, and that cannot last forever. It's just cannot. The level of value capture that's happening and the return on investment like the people who've made those investments need to get a return on them. And if we use the internet, like you mentioned, the internet as a tool, but the internet is also not free, is it? If we need to use the internet in our homes or at work, we pay for an internet service now. And so we can expect to see those kinds of costs passed on to the consumer in the future. So we can, and I think the future is definitely going to be smaller, more efficient models. But I wanted to come back to the point you were raising about innovation and appreciation. It's a continuation of the excellent point that the previous question asker made. Is, do you not feel there is a risk if we are only ever in the role of appreciator and never in the role of doing the innovation, that we will lose, as researchers, the ability to do the appreciation because we have not done the work of trying to do the innovation. So if an AI just tells us something is true and we no longer have the skills to appreciate whether or not it is true because we haven't done the hard work of building those skills ourselves.
Well, let me answer to the first part first. I think that the cost of producing AI, at least in the US, is a kind of like an overstated number. So there's a way where leaked interview with the CEO of DeepSeek that because they really charge very little in their API access, but they said even with that cost, with that number, the turnaround time of their GPU is 9 months. So only by charging that very little amount of money on the tokens, they can still buy out all of their assets in 9 months of their GPU. So these model companies are actually making a lot of money. They are not really highly subsidized. Yes, they're subsidized, but they're not subsidized by that large amount, in my opinion. And to answer the second question, I think, yes, there is a risk, especially for the next generation of people. I think because the ability to appreciate things needs very hardcore training in your undergrad or in your high school or in the grad study. That yes, people now that already been through this process, they have extremely strong ability of appreciating scientific innovations by the AI. But this is probably not necessarily the case in the future. And I am kind of pessimistic about that. Yeah. And yes, I agree there is a risk. But that is something that I think we as a whole society should do to overcome. But it's just a fact that AI is so much better at innovating than human, that human who has to shift themselves to the role of appreciation.
Sorry, just as a follow-up, could you be a bit more precise about what you mean about innovating? When you say innovation, what do you mean when you say innovation?
New ideas. Like ideas never exist in the world. I mean, that's what I mean by innovation. It's the things that no human has ever proposed. And once a person with ability to appreciate and see that idea, they can immediately recognize that it's something that's non-trivial. And that's my
have you got a clear example of that?
For example, the one I show in the slides. It's not necessarily a real innovation, I guess, but it's something that's non-trivial.
It's non-trivial, but it's I mean, I struggle to say this because I don't want to sound like harsh or anything, but it's not a very new procedure.
It's not. It's not.
In fact, depending on what your grid stencil is, you can even make it simpler. And I don't know, this does not seem like an example of innovation. This seems like an example of something which is still very useful, which is that a human doesn't know how to, so the first time I coded up something like this, it was years ago, and it took me forever. It took me weeks. And now the AI will, be able to do it like maybe in an afternoon. Now, is that a good thing for researchers? I would say, more or less, yes, okay? Because I can get to the work of science quicker. So I think the word you use, democratization, is really good because it helps somebody who doesn't have the time or the resources or the privilege to spend weeks coding something like this up to be able to do it and then use it for a different problem. But this example doesn't, it's an example of democratization. It's not an example of innovation.
Okay.
I disagree. I think this is innovation because it's just based upon the prompt. Like this is a new concept based upon the prompt that he gave the AI.
It's new to who?
To the user, right?
But innovation is, I think, unless you're defining innovation as new to you, which if that's the definition you want to use, I'm happy to work with it. But if you're defining innovation as new to like the world, new to human knowledge, this is not.
Well, no one ever came up with this for this exact problem. Again, it's about the prompt. He prompted the system to ask a very specific question, and the system came up with a new concept about that.
I don't understand how.
That thing, I'm in the middle. I don't think innovation is innovation to me. I agree on you on that. So I think, yes, this is a very good example on democratizing ideas. That if you, okay, now that I think about it, if I want to seriously define innovation as a new idea to the world, then it actually becomes a problem that is highly non-trivial to answer. How are you going to see a thing that is completely new to the world?
Yeah, my only point is this is a projection operation, which MHD codes, some of them at least have been doing a long time.
Yeah. This
So
part,
that's why
I mean this part, no, not this part. This part.
But isn't this novel for your solar physics work? Like you could publish this because it was new in that field.
yeah, so there are senses in which it's new, yes. New to him, new to solar physics, new to somebody who's never seen it yet, but
Yeah.
new to like human knowledge, definitely.
Well, would you consider AlphaFold to be a new concept, like an innovation?
Well, I'm talking about the thing that's on the
No,
screen.
but what I'm saying is that like, it's essentially the same exact thing, right? They prompted a system to say, can you solve this problem in biochemistry that's never been solved before? The system used Go and figured out how to do it. Right? It's not like it came up with some new idea, it just applied a technique that was used somewhere else to solve a problem.
Yeah,
So, and they wouldn't.
I don't have to keep the, I'm not convinced, but I don't have to keep this going, so.
I wanna keep it going. No, because I think Phil brings up AlphaGo and AlphaFold.
Yeah.
And there's no doubt that like there are, to use, I think, the very venture capital friendly phrase of like, there are emerging properties to these systems that I think are going to continue to be studied. I think we all are kind of like sitting at the fringe of hearing how math is reacting to all this with a lot of terror and a lot of kind of like what the heck is going on. I think there's still a lot of space to be doing this. That is honestly not the question that I care about as much as like, I still want to be a scientist. And I think from what I'm hearing and like I'm gonna just pose a quick thought experiment.
Yeah.
If I know for a fact that I'm never going to be one of the top 100 cellists in the world, should I never ever pick up the cello? If I know for a fact that I will never rise to the level that I will be actively innovating among the best cellists in the history of anyone to ever pick up this instrument,
Okay.
should I never pick it up?
Why not? If that makes you happy. That's my fault. I mean
That's precisely, but I think that's precisely kind of like the counter to what you described as like what our jobs will look like.
no, I think the job will still be here. I mean we are still doing science, physics, if you
Are you?
am I not?
That's the question.
Probably.
Isn't it the same thing in the future? Probably not the same thing now.
It's not. You have to distinguish between technical innovations which you can get by putting blocks, like Lego blocks together in a way you didn't do before. And you have an innovation in terms of ideas, which are completely new to everyone.
Okay.
You don't get the new ideas usually by putting blocks together in a way that is nobody has done before.
Let me use this example, but maybe it's not the best. So at least maybe that algorithm or those methods that both methods here, for example, the projection method is like really trivial to people, right? But combined,
No, I don't want to suggest that it's not.
Yeah.
trivial.
I mean, and this part is, and at least I know for a long time. I also know this part. The reason I think it's not true is that because they combine this with this method, which is this method. I don't think it's not necessarily non-trivial, but the way they combine it trivial. The real non-trivial part is that the solution that this thing produced. I mean, this is a non-trivial part.
Yes, that's.
We'll describe this as an innovation.
No.
No.
Well, I need to know more about the inputs and the outputs and stuff, but I'm willing to concede that, yes, this is a very non-trivial thing.
Okay,
And something worth publishing, absolutely, that was never my contention, so.
yeah, so if I use this to explain, for example, some hard problem field, would you consider that doing science?
Yes.
Would you consider that doing science?
Who are you
Yeah, the gentleman. I would like to consider myself doing science by doing this, even though this is prompting. But there's some human in the loop here.
Who wrote the paper?
Huh?
Who wrote the paper?
I wrote the paper. I didn't just say I wrote the paper. This
Do you write the paper or are you thinking you write papers?
I think that's like, I think I write a paper. I agree on that.
Are you doing something innovative or are you just describing what the AI has done?
To me, I'm doing something that's very satisfactory to me. Yeah.
But that doesn't mean that it's completely new.
Uh,
Even if something is non-trivial,
mhm.
that doesn't mean that it is an innovation. You can do very non-trivial things by putting together Lego blocks.
Like, I'm gonna use my powers holding the mic and it being 105 to give like a last closing statement to the speaker. And I'm glad this sparked such a discussion. I don't know if you have any closing thoughts before we thank the speaker.
I mean, my closing thought is that I will still be scientists. So I think there will still be scientists. Not necessarily me, but the world will still have a lot of scientists / physicists in the world. With the people using AI. Yeah, that's my thought. But my thought is that I think the job will not go away.
Okay, please join me in thanking the speaker. If you need to continue the discussion. Anyway, thanks for prompting us for an interesting discussion. Okay.